Hello everyone, today we'll be continuing our discussion of data collection with an overview of measurement. Now, measurement is basically where we have some kind of measured value characteristic of our population, and we are trying to determine that value using some kind of sampling or surveying technique. So, an example of this might be, say you have the population of a town and you're trying to determine the average household income, for instance. Or it could be the answer to a question. So how many people prefer candidate A over candidate B for an upcoming election? These are the types of questions that we are answering with measurement. A poll is basically a survey that involves questions and answers being filled out by the survey participants. So election polls would be an example of this, or opinion polls on other things, not necessarily politically related, or it could be anything else that really involves some question that they're answering. It could be something like, what is your favorite Star Wars movie, or something along those lines, right? I guess you could technically say that's also an opinion poll. But these are the kinds of questions that we would address using a poll. Anytime we are collecting data, we have what's known as our sampling proportion, which is basically just the ratio of our sample size, which we use lowercase n for, and our total population, capital N. Now, anytime we're collecting data, the quality of data that we collect is really important. And oftentimes, when we're dealing with populations that are very homogeneous, small sample sizes can actually be okay. The larger sample sizes tend to be required when we have populations that are a little bit more heterogeneous. Now, that does not mean that having a larger sample size necessarily guarantees that the data is going to be better. So the method that we use for sampling really matters a lot whenever we're trying to get good quality data, and we'll talk in a little bit here about some methods for sampling and data collection. Other important concepts related to data collection are the target population and the sampling frame. The target population is basically just the group or population that we are trying to get measurements for, whereas the sampling frame is the population that is actually being sampled. So if our sampling frame doesn't match our target population, this becomes a problem, right? Because now we can basically end up with biased data because the group of people that we are sampling does not match the group of people that we're actually trying to collect information on. One other concept related to this is the response rate. So this tends to come into play when we're dealing with polls. An example of this might be, say we have a poll that's sent in the mail to a bunch of people, and X percentage of the people that we send the poll to actually send in responses. This would be an example of this would be the response rate for that survey, basically. What percentage or what proportion of the people that the survey was sent to end up submitting responses. When we're dealing with sampling, there's a couple kinds of sampling bias that we can run into. So the first one of these is selection bias. So as we mentioned a minute ago, we can run into biased data when the sampling frame does not match the target population. This would be an instance of what we call selection bias. So selection bias is essentially where we have a method for selecting our sample from a population in a way that systematically favors certain individuals to be selected over others. So if our sampling frame doesn't match our target population, then basically we have some individuals within a population that are never going to be selected for our sample. this would result in selection bias. The other kind that we'll look at is non-response bias. Now, non-response bias typically comes into play with, well, kind of like what we were talking about a minute ago with, say, polls sent in the mail. Essentially, this is bias resulting from a low response rate to a survey. So, say we send everyone in town a survey that we want them to fill out, and only 1% of the people that we sent it to actually send in responses. We're likely to end up with non-response bias in this case, because basically people that are not as interested in answering our questions or are a little bit less opinionated maybe are less likely to respond. Now, when we're collecting data, there's several different sampling methods that we can use. The first one is what we'll call convenience sampling. Now, convenience sampling is exactly what it sounds like. We're just gonna pick whoever is the easiest to get to answer our questions. This would be something like, say you set up a booth outside of a mall for collecting poll data, and you're just picking whoever walks by. This would be an example of convenience sampling. One nice thing about this is it's pretty low cost, it's easy to do, it doesn't require a lot of time and effort, but the unfortunate reality is that when we collect data this way, oftentimes we're not necessarily going to get the best quality data, and the unfortunate reality is that a lot of times collecting good quality data typically requires a bigger investment of time and money and effort and all of these things compared to collecting low quality data. Sort of the extreme example of convenience sampling would be what we call self-selection. This might be something like you have flyers posted around town that have a number to call for people to answer a survey. This is almost certainly going to result in selection bias. In fact, we have a specific name for this we call self-selection bias, kind of a special case of selection bias, where basically only the people that have really strong opinions about whatever you're conducting this poll for are usually going to be the ones who respond. The next thing that we have is what we call quota sampling. Now, quota sampling is essentially sampling methods that try to force our sample to be representative of the whole population. So one key aspect of getting good quality data is that the sample that we collect has to represent our population well. Quota sampling is where we might look at the population from a standpoint of, say, how much of our population is male versus female? What's the age distribution of our population? What's the distribution of income in our population? These kinds of things. And we're going to try to collect specified numbers of data from specified numbers of people in all of these different categories to try to force our sample to be representative. Unfortunately, although this maybe sounds good in theory, it actually is really not the best for getting unbiased data. We still frequently end up with selection bias with this method because within all of these different categories that we're sampling, we're not getting a good degree of randomness or mixing within these groups. So this brings us to random sampling. Random sampling tends to be the best method for data collection. We are basically leaving everything up to probability in terms of making sure that we get a good representative sample. So we are, the simplest example of this would be what we call simple random sampling. And this is where we have our population, say we have 10,000 people that we're looking at, and we are going to randomly select 100 people from that whole population. This is really one of the best, if not the best method for collecting good and unbiased data. However, it's not always the easiest thing in the world to achieve a true simple random sample. So this brings us to stratified sampling. So with stratified sampling, we are going to basically divide our population into subgroups. We can divide those into smaller groups and so forth and so on. And then within our whole population, we're gonna randomly pick however many groups, and then however many groups within that population, however many subgroups within each one of those, and then all the way down to selecting random individuals within that. This is a very good method when a true simple random sample is not a very feasible option. Thank you for watching, as always, and I'm of course happy to help with questions.